Good evening, everyone. Welcome to today's webinar on blockchain and its career opportunities. Brought to you by the IEEE Computational Intelligence Society chapter under the IEEE Vardhaman student branch. As blockchain continues to redefine technology and career paths across industries, we are honored to have Mr. Satish Chandra, CTO of ProofMint, with us to share his industry insights. Please feel free to post your questions in the live chat throughout the session. Mr. Satish, thank you for joining us. The floor is yours.
Yeah. Good evening, everyone. I'm Satish. Today, I'm going to discuss about blockchain and its career opportunities with you all. Let me start with a blockchain introduction first, and then we will move on to the career opportunities in blockchain. So, uh, the blockchain before blockchain starts or been invented, we have we need to know the evolution of internet, because blockchain is a part of internet evolution. So let us discuss first what is the evolution. In past we have web 1.0, and present we are at web 2.0, and blockchain is the future, is called which is also called as web 3.0. Let us start with the birth of internet. In early 1960s, the internet became it's just a small project funded by the US defense government. Its goal was to create a network that could survive a nuclear attack, so that everyone can communicate through it. And then at this stage it was just starting. It was a small project, and the research is going on. And in 1980s, the World Wide Web was invented by Tim Berners-Lee. This World Wide Web is a protocol for sharing and getting access of information online. And we can know, first website went live on 1991. So how it used to be is, Web 1.0, there was used to be only read only websites, Wikipedia. Like, we can just read we can extract the information from the website. We can't just interact and all. So this is the early internet. So the advantage were, like, it was easy to create and maintain the static websites, because there were no any additional work, which we just need to serve the information over a internet. And it was quick to load and navigate. And the disadvantage were, like, it is not user centered. Like, it is not specific to a single user. We cannot interact. It is limited to plain text, images, and links. We can't log in and do stuff, right? And since these are the disadvantages, in web 2.0, it is also called as interactive web. So this interactive web makes user to able to interact with the internet, right? So these are we can have interactive and engaging user experiences, and personalized content and recommendations based upon the user activity. And because this all data, and there are also some disadvantages. Due to this, the data of ours is being, like, centralized under under certain companies, right? Even right now, when we uh, do something on internet, they are capturing their data and using this data against us. Like, we can see meta ads by if we search something on Google, we can find those ads in Facebook or Instagram, right? So they are using our own search data to show us ads for their business. So these are there is no privacy and security of our data, and these are some disadvantages of Web 2. Now comes Web 3. It is also called as decentralized web. In decentralized web, the data is not owned by a particular person. It is decentralized. So it's the next generation of internet where user data can have enhanced security and privacy over their data, and the complete control will be given to the users over his data. Whereas in Web 2, the complete control of data will be on the companies like Meta and Google. But in Web 3, the users can control his data on blockchain. And also, why blockchain is decentralized means blockchain is not owned by anyone. It is a peer-to-peer network where peers will maintain the network alive. So here are some like advantages of Web3. We have decentralized control and ownership of data. We have increased security and privacy, and and everything is transparent in blockchain, and it empowers the users to control over their data using smart contracts and all. And there are some disadvantages as well, since Web3 is a future web and it is still evolving. This decentralized web requires new infrastructure and technologies. It can't work on the old servers, old technologies, and we need new infrastructure to able to run these decentralized web, since these run on blockchain. Blockchains need a new infrastructure and technology. Maybe it is less user friendly because since it is still an evolving technology. The user interfaces for non-technical users are still bad, I would say. So we need to improve the user interface and the accessibility of blockchain to the non-technical people. And here are some differences between centralized and decentralized. In centralized, controlled by central authority like Meta, and in decentralized situation, the user has complete control over the data, and the data is vulnerable. And here it is distributed storage and compute. The data cannot be go vulnerable, and in centralized we have privacy violations and all. In decentralized we can protect our privacy. For the centralized example, we have Meta, and in decentralized examples, we have Bitcoin and Algorand. Bitcoin and Algorand are blockchains. Bitcoin is the first blockchain, and Algorand is a newer generation blockchain. So let us understand what is a blockchain first, since I'm talking about blockchain, right? So blockchain is a distributed, transparent, immutable ledger. Uh, so every transactions we are making, let's say, let's take an example. There is a shop, and the shopkeeper will keep their expenses, incomes, and in a ledger, right? So to track everything. So in the same way, uh, it is a thing for that ledger is for his business. But here in blockchain, we have a ledger where it stores all the transactions happening all over the world. And this ledger is not stored at a single location. This ledger is going to be stored around all over the world in different computers. These computers are called as nodes in blockchain terminology. And these anyone can spin up a node and create like launch their own node and maintain that public ledger. And this ledger is immutable. Once once a transaction goes into that ledger, we cannot change that. How how we cannot change is by using cryptography. We use cryptography is the like backbone of blockchain. Blockchain is built on top of using cryptography technology. So due to those like concepts in cryptography like hashes and all, we can able to maintain this immutable ledger over across different nodes across the world. So it is a distributed ledger technology since it is distributed. So yeah, and there is also one concept called consensus. Like consensus are like rules to maintain the node. So consensus will make sure the network is going good, and not any it won't allow any bad actors to manipulate the blockchain. So here are some like benefits of blockchain. Like we have security and immutability. So we the data is immutable because of uh, the data we are storing on blockchain is cryptographically hashed, and it is being distributed in multiple nodes. So a single hacker cannot target the every set of node, right? So there can be so he cannot hack a like blockchain is not a single source. So that's why a hacker cannot hack and change the data on blockchain since it is distributed over nodes across the world. And we have reduced cost. So blockchain has multiple like use cases. So when compared to a normal Web2 payment systems, blockchain can do the same thing with a reduced cost, right? And blockchain removes middlemen in that, and it can use to reduce cost in that way. And also the speed is fast. A normal process Web2 process can take greater time than blockchain, since blockchain, once we make a transaction on blockchain, it will be confirmed and added to the blockchain in like uh, 3 seconds in Algorand. These times may vary uh, by blockchains. Like each blockchain has their own consensus and own way of implementing blockchain. So these times and consensus will be different for each blockchain. So compared to uh, normal Web2 speeds, not compared to the normal server speeds, I'm talking about the process happening right now and the process happening over blockchain. So it enables us to get the efficiency and speed out of this blockchain. And we have traceability and accountability because every transaction, like since this is a ledger, every transaction anybody can go to a certain point of time and see those transactions what happened and all. So we have traceability in blockchain and global accessibility. Like in some cases, like we cannot access some Web2 applications, right? Some censor their websites in certain locations. But in case of blockchain, they can't do that because blockchain is distributed across the world. Uh, it is accessible from every location throughout the globe. And we can create innovative use cases here using blockchain, since blockchain supports logical computation as well. We can create innovative use cases on it. And we have data privacy. So we have smart contracts. Smart contracts are a piece of logic which can be executed on blockchain. We will discuss more about this in coming slides. And we have security as well and reduced fraud. So these are the overall like benefits of blockchain. And in blockchains, we have like different types. We have public blockchain, consortium blockchain, private blockchain, and permission blockchain. So we everybody knows, mostly everybody knows Bitcoin and Ethereum. Bitcoin and Ethereum are public blockchains. What is public blockchain is? A blockchain is completely available to public. So a public can participate can be a part of in the blockchain without any approval, and so anybody can participate on blockchain, and all the transactions are in that blockchain are transparent, and security is maintained through a consensus. That means everybody agrees on a certain consensus and run that blockchain. Whereas in private blockchain, uh, this blockchain is limited to certain access. Let's say there's an organization who wants to run a blockchain for their organization purpose. So they don't want to make the company's blockchain public, right? There can be sensitive info, so they will make a private blockchain, and only limit the access to of that blockchain to their company. And they can make visibility of this blockchain to certain authorized entities, and this blockchain will be only managed by that company, like that. So this is an example. So private blockchains can be useful for that type of scenarios. This leads to greater efficiency and faster transaction speed, because since only company runs that blockchain, right? So there can be faster transactions over their network. And another type of blockchain is consortium blockchain. And so this consortium blockchain is operated through a mutual consent. Let's say there are two parties who wants to there is a relationship between those two parties, and there are transactions happening between those two parties. Then we they make up a consortium blockchain, and operate through mutual consensus, and make the transactions on that blockchain. So in that case, we can use consortium blockchain. And we have permission blockchain, where the access to the blockchain can be permissioned based upon the permissions from the identity. They can mandate identity verification. They can uh, give only access to the like other holders. Like they can make up a blockchain as permission, like that. This is an example I'm saying. So there can be like many use cases with permission blockchain. So the idea is to give access to the blockchain based upon the permission. And we have some public blockchains where, as told, like Bitcoin, Ethereum are like most famous public blockchains. And we have some other newer generation blockchains like Algorand and Solana. And Litecoin is also a public blockchain. So let us discuss like what is a consensus algorithm. So to prevent bad actors from manipulating the data on blockchain, and ensuring that the transactions which are being recorded on chain are valid, and to do that we need consensus. So consensus will allow participants uh, to, like, we cannot trust the other actor in blockchain. Not only in blockchain, we cannot trust the other party who is not known to us, right? So we need to for every second new transactions are coming. How do we decide this transaction is valid or not? How do we add those transactions to the blockchain? So to make up this process, consensus algorithm will be running on every node of that blockchain. So consensus protocol ensures that all nodes agree on the order of transactions, and every transaction is uh, true, like it is not a falsy transaction. And then only those transactions will be added to the blockchain, right? Without every every node not every node, there is certain steps. Like every consensus algorithm is different, but the main core of the consensus algorithm is to uh, do this. Everyone agree upon the order of transactions, check whether the transactions are valid or not, and bundle up those transactions and add it to the blockchain. This is the process where a consensus algorithm is going to do. And this ensures uh, consensus ensures that blockchain runs smoothly without having manual effort. So nodes are going to uh, do the this entire checks and all, and it will take care of if some nodes are offline or faulty or malicious. The consensus protocol ensure that they are removed from the network. So this is the definition of a consensus algorithm. So it also like prevents attacks, right? There can be a DDoS attack. Someone might spamming up transactions to the nodes. So these nodes will ensure that no policy transaction enters the blockchain, and it is responsible for the block generation and preventing the double spending. I have $100. If I try to spend $200, the consensus won't allow to do that. There are many consensus algorithms that are being used right now. For example, Bitcoin uses proof of work, Ethereum uses proof of stake, and Algorand uses pure proof of stake. Solana uses proof of history. So every blockchain has its own way of implementing their consensus algorithm, and they name the consensus algorithm like this: proof of work, proof of stake, proof of history, proof of. So let us discuss proof of work, like how Bitcoin implemented their consensus algorithm. So Bitcoin has a consensus algorithm where miners will compete to solve a mathematical problem based upon the SHA-256 hashing algorithm, and whoever solves this mathematical equation first, they will has the right to do the block generation and the block validation and block creation. So miners who are doing this work will receive rewards. So every consensus algorithm has an incentive to pass upon, because nobody will give up their resources, hardware resources, electricity, uh, for free, right? So to compensate that, every consensus algorithm will give rewards based upon their definition. In proof of work, for every block, there will be a miner who solves the algorithm, like the mathematical problem first, and that miner will do the block creation, block validation, and block addition to the blockchain, and that miner will receive the reward for solving for doing this entire work. So the the mathematical equation is like, there is a value called nonce. So they have to find this nonce, and only a valid nonce can be added to a block. Otherwise, that block cannot be added. So they will find this valid nonce, and whoever find this valid nonce, they are the winners for that round. Once it is generated, it is easy to verify the block, and but this needs a high energy consumption, because not only one person, every node on blockchain are going to do the same computation, and it is energy. So we are wasting the energy here by doing the same computation over hundreds and thousands of nodes, and it is a longer process. So that's why Ethereum came up with proof of stake. In this consensus, it requires users to stake their money, their cryptocurrency, to be a validator. Uh, so validators are responsible for adding and confirming the blocks on blockchain, and these here also, for every round, a validator is selected randomly based upon their stake, and that validator will do the work of uh, grouping, creating a block validations of the transactions and adding that block to the blockchain, and they will receive the incentivization for this work as well. And it is not easy to manipulate because even after a single node is selected randomly, the hacker cannot find this block creator at that point of time. And after block creation, there will be block validation by other nodes as well, and it is not easy to do. And so the hacker cannot hack all the nodes at once, so it is not easy for the hacker to break this consensus as well. And there is another consensus algorithm for pure proof of stake, which is used by Algorand. This uh, this has same approach as like proof of stake, but here we use VRF, verifiable random function. So this verifiable random function is like created by Silvio Micali. He's a Turing Award winner in cryptography. So this in proof of stake we are selecting randomly based upon their stake, but here we can verify that uh, random selection on blockchain. So it is not just random, we can verify that random choice as well on blockchain. So e- each block has like a proposer and a committee. Committee is a set of nodes and proposer is a single node chosen randomly using VRF. And there can be multiple committees. The chosen proposer will create the block and do the validation of transactions, and this validation will be passed upon to the committee to approve. And the committee, after approval of the committee, the block can be added to the blockchain. Here also, since it is a verifiable random function, it is more secure and verifiable on blockchain. And these entire proof of stake and pure proof of stake does not require heavy computation because they are not solving the heavy mathematical equations and all. So since it is very simple process by selecting random actors and doing this takes less energy and takes less than 4 seconds. Let us discuss about wallets. So wallets are like key part of blockchain since uh, these are like identifiers on blockchain. Think blockchain is like a country. Uh, Wallets are like the identities like Aadhaar in a country. So we cannot live in a country without an identity proof, right? In the same way, we cannot involve in blockchain without a wallet. There are different types of wallet, software wallets and hardware wallets. Software wallets means these wallets will live in your uh, systems like laptops or mobile phones in a software, whereas hardware wallets are like they are separate devices where the keys will be in those devices. The examples for software wallets are MetaMask, Trust Wallet, and the example for hardware wallet is Ledger. Ledger is a company which manufactures these hardware wallets. So it will be like a USB drive where we can store our keys in that. So the advantage of hardware wallet is it is not exposed to other environments. Those keys will live up in that USB drive only. So it is more secure than the software wallets. And also there are like so many hacks happened over software wallets. Like recently, Trust Wallet has been a newer version of Trust Wallet has been hacked. Like a hacker has created malicious code that steals the private keys. So so that's why so this update made a 7 million loss to the users across the globe. So that's why everyone uses hardware wallets uh, as an wallet for blockchain for their security. And in blockchain, we have this thing called smart contracts. So smart contracts, initially when Bitcoin was launched in 2008, we only have a ledger which consists of the transactions. We do not have smart contracts on blockchain of Bitcoin blockchain. Uh, but after 2015, Ethereum came up with this new thing called smart contracts, where a certain piece of code can be executed on chain, so that it cannot be altered, or nobody can uh, alter this code and do malicious thing over certain logic. So this smart contracts automatically execute over this blockchain, and nobody has uh, right to change this, right? So it is completely transparent. So that like this is an innovative part of blockchain where we can write our own logic over through smart contracts, and we can publish this smart contracts on blockchain, and then anybody can execute this code by invoking by calling the transaction on blockchain. So these are programs written by developers, and these after writing the programs, these programs are going to be stored on blockchain as Ethereum and Algorand. Smart contracts are stored uniquely, and each contract has their own address or identity. Uh, in Ethereum, after we create a smart contract on blockchain, we get a public address, and in Algorand, after DApp is a terminology called decentralized application. If an application includes a decentralized element in their application structure, then we call it as DApp. So, in simple terms, we can use smart contracts as a backend for our application. So this which can be executed whenever someone submits a transaction. And we have cryptocurrencies and tokens. So cryptocurrencies are like a digital money. So we we have Bitcoin, Ethereum. These are blockchains, and they have their own primary currency in their network. For example, Bitcoin has BTC. BTC is their network currency, and ETH is the network currency of Ethereum. So I have told you that for doing the consensus work, they will get paid for their work and the resources they're providing, right? So they will pay in these cryptocurrencies. And who are the users who are using the blockchain will also use this cryptocurrency as a payment method for these transactions. Those are called as gas fees. So they have the ability of doing some transfer of these cryptocurrencies on the blockchain. They can transfer Bitcoin from one wallet to other wallet. That means one person to other person, and so this network will handle this currency uh, by the code which is written like predefinedly. So nobody can create as much as money they want. This money will be created by the consensus itself. Uh, from the consensus only, these coins will be created for each block to maintain the sustainability of the network. And so these cryptocurrencies or tokens can be shown as the proof of payments. Since those are currencies, we can show them these as the proof of payments, and so it is fully automated. No one will control this money on blockchain. And we have dApps. So dApps are I have also already defined the dApps definition. It is an application that runs on blockchain. Their core logic runs on blockchain. Then it is called as dApp. So dApps can contain information beyond financial transactions. They can store data on blockchain using smart contracts. They can define a business logic uh, in the smart contract. So nobody can do some these kind of things, remote execution or code injection. Since it is a blockchain, this logic will be secured forever. We have some financial use cases like cross-border payments. Even so, right now, if I want to transfer some money to other country, it would take a lot of days. We use banks, right? So using a bank, if I want to transfer 10 rupees to uh, convert the to US dollar or transfer that US dollar to someone in US, I can do that, but it will take a lot of time, like 2 3 days. So, but over blockchain, we can send the cryptocurrency uh, in seconds, and we can use blockchain for every financial product which is in web 2 right now. We can make the financial products which are in web 2 as decentralized finance, so those are called DeFi. And also we can tokenize the real world assets over blockchain and make them fractional. So these are some use cases of blockchain. And these are some non-financial use cases, like we can use blockchain in supply chain, healthcare, identity, voting, because blockchain is has identities, and since it is transparent, we can use in these type of non-financial use cases. Let us end the introduction to blockchain and the overall concepts within the blockchain. Let us come to the career opportunities in blockchain. Since blockchain is a newer technology, we require a lot of workforce to make more and more usable applications on blockchain, right? So since it is an evolving technology, definitely like we need more number of developers in future. So the main primary job roles which we can look out for is like smart contract developers. Since smart contracts are newer type, right? Those cannot be created using normal languages. So they require a special knowledge, right? We need to understand blockchain, all these concepts in deep, and then we can able to write smart contracts. So smart contract engineer is a role where you can look upon for the career opportunity in blockchains. So smart contract that smart contracts can be developed, and also all the roles which are in web 2 right now do have a web 3 role as well. Like, let's take a UI UX developer. A normal UI UX developer cannot create an interface for a dApp. dApp is different, right? dApp requires the usage of wallets, assets, tokens, cryptocurrency. So you need to think a blockchain as an additional skill over the normal developer thing. So smart contract developer is a separate category. Since it is completely related to blockchain, it is a separate role. But we can think full stack developer, UI UX developer, project manager. So these roles has can have an additional skill called blockchain, and we can, after knowing blockchain, we can implement the UI UX thing. We can add blockchain as a skill in our role that gives an edge over other candidates. So these are some like career opportunities we can look upon in blockchain. So every role which is in web 2 can be used in a web 3 career opportunity as well. And the resources are low, so that's why the count of the developers in web 3 is low. So but in future we do definitely require more number of web3 developers. Web3 developer means like the developers with has an expertise in web3. That's it. So the existing developers can also who has a knowledge of web2 can also learn blockchain part and become web3 developers. Even I have started my journey by learning web2 technologies, and after that I have learned blockchain and became a web3 developer. So these are some career opportunities you can look upon. Yeah, yeah, this is the end of the session. Thank you for the opportunity for the for Vardhaman College IEEE team.
Thank you, Mr. Satish Chandra, for that insightful session on the evolving world of blockchain and the career path it offers. We are truly grateful for the time and expertise you shared with us today. I would also like to thank the IEEE Computational Intelligence Society chapter and the IEEE Vardhama student branch for organizing this event. Finally, thank you to our audience for your active participation and questions. We hope this session helps you in your professional journey. Have a great evening, everyone. Thank you.